Welcome to the Intelight tutorial 203. This tutorial will show you how to program a HAWK Ped inside of Maxtime. The first thing I'm going to do is load one of the standard HAWK databases and watch the sequence and see the logic of how it happens. I'm going to pick the HAWK TS1 database, and when I set it as active, it says it'll be effective on reboot, so I'm going to reboot the control. In Maxtime, the HAWK Ped is a simple two-phase intersection. There's a vehicle phase on one and a ped phase on two. What we're going to do, we bring out the vehicle phase on two separate channels so that we can do the wig-wag flash. So I'm going to open up the channels. So right now we're channels 1 and 2 is vehicle phase 1, and we're dwelling in green. So I'll put a call in for the ped on phase 2. It immediately starts flashing yellow to let people know that the walk is coming up. It goes to a solid yellow, and then the ped comes on. So we're in a walk movement. The reds are solid on the first two channels. I go to my flashing clear movement, and I have a wig-wag flash up here. So this will clear the phase and go back and dwell in the green, but the greens aren't hooked up. So this is a dark signal until some. Now I'm going to show you how to program this from scratch. So I'm going to go back and load a default 8-phase quad database and program this controller into a HAWK Ped so you can see all the detailed steps required. So I've loaded a 8-phase quad, and you can see that I'm running 8 phases. It's cycling around. I have recalls. So my first step is to go into the sequences, and I'm going to remove all the phases I don't need. I just need phase 1 and phase 2. Phase 1 is my vehicle phase, and phase 2 is my ped phase. Of course, I have to go to my phase configuration, and I don't think I want to start up in walk, so I'm going to say phase 1 start up in green, no walk. In phase 2, my ped phase, I'm going to say don't time it on startup, so that and I'm going to go through and I'm going to remove the other phases just to make it clean. It's always good to clean up your program, and this is all that's really necessary, but I like to put a little description in, and I'll just put in, phase 1 vehicle. It's of course a phase 1 vehicle, but I should say vehicle only. But down here I'll put in, phase 2 ped only. So we have a ped only phase and a vehicle only phase. Hit apply to that. And the next step will be the phase options. So when I go into the phase options, I need to make this shrunk it a little bit too much there. So I want to get rid of all the other stuff just to clean up the programming. If it's not in the sequence, it's not going to be used, but it's housekeeping. So I'm going to remove all the check marks here except for making the detectors non-locking. And I certainly want to always go back to phase 1. So I'll put phase 1 in soft recall so it always returns there. And I will hit apply. Then I go in and put my phase time then. So phase 1, I don't want any ped timings, but 2 I do. So I got some 8 seconds of walk, 15 seconds of don't walk. I'm going to keep the default green, yellow, and red on the vehicle, but I need to go down and put in some pre-clearance value. This is the flashing yellow before the solid yellow is the pre-clearance, and I'll put 5 seconds. The next step is to go in and check our detectors, and we got vehicle detector 1 going to phase 1, and we got ped detector 2 going to phase 2 ped. We'll go into the channel configuration, and these are load switches. So the first 2 load switches need to be vehicle phase 1, and the third load switch needs to be ped phase 2. So I'm going to rechange this around. You don't have to remove the other ones, but I always do just to clean up my programming. So I'm going to drop these down, select other, put zeros in so that when you look at the database it looks a little bit more professional. Should always do that, then you never have a problem. So certainly take a look. So you got load switch 1 and load switch 2 are both phase 1, but we're going to wig-wag the reds. That's why we need 2 load switches. So when one red's on, the other one's off, vice versa. So all you really need is a two-phase load bay with 4 load switch sockets. You can use 3 and have a spare. The next step is that pre-clear value. Right now the pre-clear, we want the yellow to be alternate flashing so that we can flash that guy. We hit apply, and that's our programming. So now we're going to go in and we're going to write a little logic to handle this one red on a half a second, the other red on the other half a second. So we're going to create a global variable, and we're going to set it to a logical statement. So it's going to be the active phase in a ring, and we need to define what ring. So it's going to be ring 1. So when ring 1 and the active phase is 2, so when phase 2 is on, local variable 1 is true. So I'm going to put a little text in here, phase 2 in ring 1 is active in ring 1. Sounds good. And I got some other text that should have been deleted previously, so I'm going to clean this up while I'm over here on this side of the page. So I need to find that phase 2 is active in ring 1. And then I'm going to create another local variable and look at the PED. So I'm going to say local variable 2. And I'm going to look at the PED interval. So I'm going to make it logical. And I'm going to say ring PED interval. So what ring again am I talking about? So I'm going to look at ring 1 again. So is phase 2 active? And is the PED interval active? So we say, okay, phase 2 is our PED phase, and then what interval? So I'm going to pick number 5. So number 5 is our flashing don't walk interval. So we'll put that in. So I can define that not only the phase is active, but also a particular interval on the PED is active. And now we're going to come back and we're going to create another local variable number 3, to compare local variable 1 and 2. So what we want to compare is when they're not and. So when phase 2 and the local interval are not and together, when they're both not true, then local variable 3 is true. So we're using a NAND operator. So we get that. So the next step will be to create a couple global variables, because the global variables are outputs. So we're going to put some logic on them, assign them to the 2 red pins, and we will get our wigwag flash. So we go back here and we pick global variable 1. Global variables retain their value for each loop, so we know what it was the last pass through. We can also assign those to output pins, or we could pass them to subprograms and pass it back. So global variable is a very powerful operator. So we're going to assign that to the phase 1 red, and then we're going to make global variable 2 when phase 1 red is not on. So we're going to pick the resultant of not instead of true. So we get our phase 1 red. Oh, we got to go back and make it resultant not. So, and if so we want to jump some lines if the local variable is true. So the next line we're going to put in is to jump. So we're going to say jump a number of lines if B is true. So we're going to say a jump, the number is going to be 2 lines. So we're going to put 2 in there. And the qualifier on the if is going to be local variable 3. So if local variable 3 is true, we're going to jump down 2 lines, and we're going to turn one of the reds on. So we'll put that in. And the last 2 lines of this little program are setting the global variable colors. So we go out and we drop it down and say global variable 1, global variable 2, So we're only going to jump to the second line conditionally. If it's not true, we're going to run the second line. So we go down and we put them, the not symbol in, and we have our channel drivers. One, channel 3, which is our PED channel, and our PED channel. We hit apply. Got to get it all set right. So this is the entire program you need to handle the wig-wag flash in a HAWK Ped. So everything looks good. One last check across. We go down, we hit apply, and we're good to go. So we will go to the next. Don't get lost in this logic program. You can always just load a default HAWK Ped and go in and look at it. The point is that you can write this logic and you can do the workaround. The last step is taking our two global variables and assign them to our two red output pins. So we go to outputs and assign them. The next step is watching the actuations of how this controller is running now that we have it programmed. So we go back to our status screens, and right now I had it in running recall, so it's going through the flashing don't walk, and it's doing the wig-wag flash. It will complete, and now it's gone back to be in a green state and a dark signal. So channel 1 and 2 are dwelling in green. We'll apply the call. We immediately go to the pre-clearance. So we're flashing the yellow on the vehicle phase, telling people that yellow is coming up. We have our solid yellow. Then we go to our walk. So our walk is on. We have two reds on. So channel 3's in the walk interval. And then we go to PED clear and we're back around again. So this is just to verify that we programmed everything correctly. Always good to test it. So I guess that does it. Thank you for watching this tutorial with me. I hope you found a few tips or tricks along the way. Just remember, the easiest way is just to load the database and adjust your walk times and your PED clear, and of course your pre-clearance value for the amount of yellow flash.